All right, hello Algebra 1 honors. As you're watching this video, take notes down just like you would in class. Act like I'm standing over you, making sure you're writing everything down. But this is your direct instruction. We're not going to teach this. I'm not going to get up and do notes on the board over this. This is your notes, okay? This is you learning new material. What we're looking at is section 2.5, solving compound inequalities. And this is an interesting day. What compound inequalities are is where you've got basically more than one inequality put together. Okay, so actually, and then this is a situation that actually occurs quite a bit in the world that we live in. Let's start off with an example here. For this example, our instructions are to translate and graph. Translate and graph. And we've got a number C is less than 5 and greater than or equal to a -2. A number C is less than 5 and greater than or equal to a -2. Well, let's start off with, let's transcribe what we know here. It says a number C is less than 5. Well, that right there is a simple inequality. C is less than 5, okay? So no big deal there, but it says and C, or it doesn't say C, but they're talking about C, and greater than or equal to a -2. So I'm going to write out an and right there and say that C is greater than or equal to a -2. And this is a compound inequality. C is two things at the same time. Less than 5, greater than or equal to -2. Now, if you think about this on a number line, if you're less than 5, greater than or equal to -2, what that means is that basically C is between -2 and 5, right? It's greater than -2, less than 5. So C is in between them. And you're actually going to write it that way. So C goes in the middle, and C was less than 5. But C is greater than or equal to a -2. It's in between. And that's the way you're going to want to translate it. Whenever it's an and, you can think of it as being in between, and you can write your compound inequality this way. And this is called an and compound inequality. Now to graph it, you make a number line, and I'm not real picky on these. I just want you to have the smaller number on the left, the bigger number on the right. You don't have to put all the numbers in between. But here's the thing, you're going to actually have two dots or circles. Is it going to be a circle or a dot at the 5? Well, because there's no equal sign, you're going to put a circle. Circle or a dot at the -2, well, it's going to be a dot because of that equal sign. And then C is in between them. C is less than 5. C is greater than or equal to a -2. So what we do is we shade in the middle, like so. And that's the graph of a compound and inequality. All right, another type could be like so. Still translate and graph, but we've got a number T. A number T is less than a -1 or greater than or equal to 4. So when you start out translating it, just kind of go step by step here. It says a number t is less than -1, no problem. Then it says or. Okay, so or greater than or equal to -4. So we're still talking about t. We're still talking about t. So t is greater than or equal to 4. So now let's think about what this is saying. T is less than -1, or t is greater than or equal to 4. This is not going to overlap. T is not between them, okay? T has two separate areas that are solutions, okay? So because it's an OR problem and you can't smush it together into one answer, you keep it separated, and this is an OR problem, and OR problems stay separated. And let me show you on the graph if you're having trouble visualizing this. -1 is to the left, 4 is to the right. Circle or a dot. That's right, circle. Circle or a dot. Yep, it's a dot. And then check it out. Greater than or equal to 4. Less than a -1. So you shade on the outside. Now, early in my teaching career, I used to say that and problems were and problems were a mustache, and or problems were eyebrows. I don't think that really helps you remember anything, but it's kind of fun, I guess. And then you get somebody being smart and say that, well, this is a unibrow. But anyway, so there you have it. That's your introduction to solving compound inequalities. You can have and compound inequalities or compound inequalities, and you need to remember that and compound inequalities get rewritten as a single inequality squished together. All right, let's look at solving these. Okay, let's look at solving these. I'm going to go ahead and erase these. Hopefully you got it all down. New marker, leaving its mark there. So that was translating them. Now let's move on to solving them. Solving them. So the instructions are graph the solution. Graph the solution. And our first example is an and compound inequality. It says -3. Then you got the less than symbol, x plus 1. Then you got the less than symbol, 5. And this is actually saying x plus 1 is between 5 and -3. And it's not equal to either one. Now, you do something interesting when you solve this. What you do is you isolate x in the middle. So to undo adding 1, to do the inverse operation, we're going to we're going to subtract 1, and we subtract 1 here, and we subtract 1 here. We cover all sides, I guess you could say. We cover all our sides. So we get -4 x 4. And remember, this actually says x is between 4 and -4. And when we go to graph this, -4, 4, circle, circle, shading in between. Shading in between. Oh, by the way, I should mention, if I go too fast, you can always pause the video, which is super nice about the videos, is you can pause them and kind of catch up. If you misheard something or you need to hear it again, you can always back it up. The videos are kind of nice that way. All right, what do you think? Feeling pretty good? Let's try another one. -7, less than symbol, -3w, -4, less than or equal to symbol 2. This is another and problem. And we still want to get W, solve for W in the middle. I could divide every single thing by a -3, but that would introduce fractions and stuff. Let's go ahead and add the 4 once on each side, and we get a -3 is less than -3W less than or equal to 6. Now I'm going to divide by -3 everywhere. And I'm going to get a 1. I'm going to get a W. I'm going to get a -2. But class, what did I just do? I divided by a -3. And when we do that, it changes the inequality relationships. They flip. So we're going to have that and that right there. Now here's the thing. On and compound inequalities, when you divide by a negative and the signs flip, you do have to take a moment to rewrite this. And compound inequalities always need to be written with the smallest number first, okay? So we're going to flip this around and write -2, 1, W, and then it's going to be, so this is W is greater than, so W is greater than or equal to -2, W is less than 1. We do have to flip it around, okay? So just be on guard for that. If you end up dividing by a negative and flipping the signs, you're going to have to rewrite it so that the smaller number is at the beginning. And then we'll graph it, -2, 1, dot, circle, shades in the middle. All right, you can throw it away. It's fine. Let's see. Let's do an OR problem. Do I have room over there? Probably not. Okay, let's go ahead and erase this. We're still graphing the solution, but let's do one more here. This is an OR problem, so we're going to have 2x plus 6 is less than -2, or 4x minus 5 is greater than 3. And on these OR problems, you're basically just solving two inequalities. You solve each one separately and then graph them. So it's kind of more work in a sense. Oh, check this out just for kicks. I'm going to divide by 2. Divide by 2. Where else do I need to divide? Right there. Division and multiplication, distribute. Now the reason I'm doing this is just for one, to show you can, but also these are all even, so it turns out nice. So I'll get x plus 3 is less than -1, and then I subtract the 3 over, and I get x is less than -4. Move over here. I could divide everything by 4, but ugly fractions. So instead, let's add 5 on each side. 4x is greater than 8. Divide by 4, x is greater than 2. We write OR in between them, and we are done. We go to graph. -4 is smaller, 2 is bigger. Circle or a dot on the -4. Circle. Circle or a dot on the 2. Circle. And then x is less than -4. That's shaded to the left. X is greater than 2 is shaded to the right. And there you have it. I don't think a lesson would be complete without a word problem. So let's do a word problem, and then we'll call it good. As you know, with the word problems, I encourage you to write them down. Let's see here. A little bit of words, okay? The recommended storage temperature, I'm pushing the boundaries there, aren't I? Oh, it went off a little bit. Okay, the recommended storage temperature for chocolate is from, or I should probably say between, but we'll say from 15 degrees Celsius to 20 degrees Celsius. I guess that actually would mean something different. Okay, the recommended storage temperature for chocolate is from 15 degrees Celsius to 20 degrees Celsius. I know I'm off well here. I'll just slide it over just a little bit. There we go. Okay. Find, this is kind of fun. Find the possible temperatures in degrees Fahrenheit. Find the possible temperatures in degrees Fahrenheit. Okay, so the recommended storage temperature for chocolate is from 15 degrees Celsius to 20 degrees Celsius. So you could be 15 degrees up to and including 20 degrees. And then here's the thing, they want to know the Fahrenheit, the possible Fahrenheit degree temperatures. Well, this formula is going to help you out, and we will always give you these formulas. But it's converting Fahrenheit to Celsius, and it goes like this. This is probably familiar to a few of you because we've worked with this formula already this year, rewriting it. But now what we've got is we've got degrees Celsius, and we want to convert it to Fahrenheit. But let's think about what the relationship's going to be here. The relationship is, I would think, it's going to look like this. It's in between, isn't it? It's from 15 degrees Celsius to 20 degrees Celsius. I'm going to think of this as an and problem. So we've got 15 degrees Celsius, 20 degrees Celsius, and the Fahrenheit is in the middle, okay? So what C is equal to, the temperature, goes in the middle. So we've got 5/9 F minus 32 is going to be less than or equal to 20 or greater than or equal to 15. You can be 15 up to and including 20 degrees. And that's the setup for this. What we're going to do is we're going to solve for F, which will convert our answers to Fahrenheit. So to do that, what would you do? Well, I would not distribute the 5/9. I would multiply by 9/5. And I gotta multiply here, which will undo that. I gotta multiply here, and I gotta multiply here. Now, don't grab your calculator so fast. 5 goes into 15 3 times. 3 times 9 is 27. We're going to drop the degrees Celsius because it's going to turn to Fahrenheit. Divide out, divide out. Now you might be thinking, why don't you have to distribute it here? Well, because this multiplication. This is a multiplication. This is a product, and so when you multiply it, it undoes before it has a chance to distribute. You undo the multiplying by the reciprocal before anything else can happen. So you're just left with F minus 32. 5 goes into 20 4 times. 4 times 9 is 36. And then we're almost done. We got to add the 32 over. 36 plus 32 is 68 degrees. Oops, 68. Add the 32 over, that will be 59 degrees Fahrenheit. have it. It says find the possible temperatures in degrees Fahrenheit. Well, the degrees Fahrenheit can be needs to be in between 59 degrees and 68 degrees. But notice we include the 68 and the 59. And there you have it, a sort of a real world application there for you. Well, the practice for this is in Big Ideas, and it's page 85, numbers 3 through 29, odd. Excuse me, 3 through 29, odd. I would say you could do every other odd, and I'll still leave that as an option, but this is new to you, I'm almost positive, so I would recommend getting as much practice as you can. 3 through 29 odd. Maybe do some evens if you feel like you need more practice. Make sure you check your answers, okay? Check your answers on Canvas. Hey, thanks so much for watching. Have a great day without me.